Okay, what is the empirical formula of a compound containing 25.9% nitrogen, 74.1% oxygen? So again, what we do is we assume we have 100 grams of compound, which means these percentages are effectively grams, because in 100 grams of compound, 25.9 grams would be nitrogen, 74.1 would be oxygen. So the first thing we do, we will figure out moles for each of these, 25.9 grams of N times, we'll have grams of N on the bottom, moles of N on top. 1 mole of N is 14.01 grams of N. Again, we just get that from the periodic chart. This comes out to be 1.85 moles of nitrogen. We'll do the same for oxygen, 74.1 grams of O times grams of O goes on the bottom, moles of O goes on top. 1 mole of O, 16.00 grams of oxygen, is going to come out to be 4.63 moles of O. The next thing we want to do is divide each of those through by the smallest one. So we know that for nitrogen it will be 1.85 moles divided by 1.85 moles. That's going to be 1, and that's for nitrogen. And for the oxygen it will be 4.63 moles divided by 1.85 moles. And that's going to come out to be 2.50. So what we've got here is something where we don't have whole numbers. So what we do is we look at this one and we look for what common fraction 0.50 would be nearest to, and that would be 1/2. So that tells me that what I'm going to do is take both of these and multiply them by 2. So at present we've got N is to O is 1 is to 2.5, and if I want to make those both whole numbers I can multiply it by 2, and that's both numbers by 2, and that's going to give me 2 is to 5. So that's how I end up getting my empirical formula as being N2O5. And just in case you don't believe me, take the 2 divided into 5, if you take the 5 divided by 2, that's going to be 2.5. So it's going to be 1 is to 2.5, which is the same as what we had just at the very beginning here.